Hey, everybody. Welcome to Talking Serverless. I'm the host, Paul Chin Jr., Senior Serverless Developer. Today's episode is brought to you by Serverless Guru. We're your ultimate guide for all things serverless. If you're a Fortune 100 company looking to adopt the cloud and make the serverless push a reality, you give us a shout. And today, I've got a really exciting guest. His name is Matt Butcher. Almost needs no introduction, but I will kind of let you in on what he's been up to. He's an open source leader, and he's the CEO and co-founder of this new thing called Fermyon that we'll get into. And of course, today we'll be talking about serverless. So with that, Matt, why don't you kind of quickly introduce yourself to our folks who don't know who you are?
Yep. Thanks for having me. I'm super excited about this today. And my background in cloud kind of goes back. Actually, before that, I was a CMS person and used to do a lot of Drupal and PHP development. And I was doing that at HP right around the time HP got really into OpenStack. And that coming into contact with a managed cloud and the sort of it rocked my world, right? It broke down that kind of one-to-one thinking I had that every piece of hardware has exactly one operating system, and really changed the way I looked at how I thought development was going to go into the future. And I got so excited about cloud, left at HP, shifted from the CMS team into the cloud team, and then have just been going ever since. Went from there and did some IoT, cloud side IoT stuff. That company got acquired by Google, spent some time at Google, which is, I mean, talk about serious cloud computing. My first glimpse at how Google did things internally was like absolutely mind blowing. But I went back to startups from there and went to a startup in Boulder called Deus. We were building a PaaS based on container solutions. And we were really kind of the first ones to do this, which ended up getting me into Kubernetes, and then on into these days with Fermyon, we're working on serverless and WebAssembly. So it's been quite a ride, but it's awesome to work in the field that you really feel the most passionate about, and that's where I am every day.
Dude, I so appreciate your enthusiasm for cloud because you're attached to some of these really high visibility projects like Helm and Krustlet. Were you there in the early days when it was just Borg?
It was so yeah. I mean, so the story there was, I was working for this IoT startup in Boulder called Revolve, and I was leading the cloud team there. And they acquired us. Google acquired us and rolled me into the Nest team. And Nest makes the smart thermostat and smart fire alarm, and they were really growing their product line at that time. But Nest had only been acquired by Google maybe 4 or 5 months ahead. And so Nest was still on their orchestration system, which was shockingly very, very sophisticated. For a company that makes thermostat, their cloud platform was awesome. But they hadn't yet moved over to Borg. And so I was there kind of observing the transition as they started working on what's this Borg thing? How does it work? And Google really is one of those companies where once you're inside, you can kind of poke around at just about everything. And so I was building little Borgy applications with the internal version of App Engine. And that was a big shift in the way I looked at orchestration, coming from OpenStack, where a lot of our orchestration was done via Chef. Borg's very declarative. And so I really liked and very much enjoyed it, though Borg is very sophisticated. And so when I was at Deus, after leaving Google, and we were building this open source competitor to, Heroku and that sort of PaaS, I was there when they released Kubernetes, the very first version of Kubernetes. I was and looked at it and went, this is like all the good parts of Borg. And it is so much simpler to use. And at the time, Kubernetes was very simple. I mean, we only had I think 5, maybe 6 different resource types. You could basically be a pod, a replication controller, a service. It was very, very straightforward. And so at Deus, the team that I was working on at Deus, we looked at this and went, we should just build our PaaS on top of Kubernetes. And that's kind of actually what got us started. We created Helm because we needed to install our PaaS on Kubernetes. We got all these exciting projects really started from, that recognition that the Borgy way of doing things that Kubernetes introduced was going to help us, make leaps and bounds where before we were having to write lots and lots of software to do our own orchestration. I think I I kind of hate to admit how big of an influence Borg had on the way my career has gone, given that I wasn't at Google very long and never worked on directly on Borg, but just a glimpse of how that system worked very much changed the way I viewed cloud services and orchestration.
I mean, that's interesting because that's really the birth of what cloud native really means, right? It's about having this abstraction over the entire distributed system, right? Where you have a standard API and you're like, okay, I can hook into this specific programming model given this interface. And now you're no longer worried about individual machines or individual processes.
Right.
You've
Yeah.
got a higher level kind of construct in front of it. And like I prepared a little bit. I was like, I wore my Google Next shirt from when I went in like 2018, I think.
Nice.
That was wild time at the Moscone, and just seeing all of the way Google does things internally for like a little bit. I was never a real like noogler, but I have friends that went through it. Um, so can you tell me a little bit more about how Helm came about and what you were doing with it, and like
Oh yeah.
the maybe like a yeah, like tell me the origin story of this Helm thing, because I have to use it every once in a while, begrudgingly, to be honest. But like you were there, that's really exciting.
Yeah.
Tell me about it.
Yeah. I had a background in building package management systems before. I worked on one of the early Go package management systems called Glide. Even back in the PHP days, I had been really involved in the PHP package management stuff, and so that was kind of a background that just sort of lived with me as I went through things. So we were at Deus, and my team, which was sort of the R&D team at Deus, was experimenting with replatforming our entire PaaS on top of Kubernetes, and the at some point, what we were discovering in the experimentation was we could just vastly simplify the way we were doing things if we switched over to Kubernetes. And so I went and pitched it to the executive team at Deus, and they liked the idea, and they said, "Well, we got this offsite coming up in a week and a half. How about if you go up there and you introduce Kubernetes, and then we'll do like a hackathon to get people involved in this new Kubernetes thing." And I was like, "Oh, that sounds like a great idea." And they're like, "Yeah, so we're going to give you the spot right after lunch to introduce Kubernetes." And I said, "Oh, ouch." And they're like, "And everybody in the company is going to be there." And I'm like, "So like all the engineers?" And they're going, "No, like finance and marketing and everybody's going to be there." And I'm going, "Oh, this is a tall order." So I took some of my kids' stuffed animals, posed them, took some pictures, and built a little slide deck that I jokingly called at the time the Illustrated Children's Guide to Kubernetes, even though there was no illustrations in it. It was just, and then and that actually, someone in marketing in the room, Karen Chu, was in the marketing department there and was like, "Oh, we should totally make this into a real book." And so that's actually how the Illustrated Children's Guide to Kubernetes got started. But then 2 hours after that, we kicked off a hackathon, and my team was going, so maybe we could like build a package manager for Kubernetes. We really needed a way to easily install Deus workflow into different people's Kubernetes clusters. And so it was solving a real business need, and we had some background in it. So we originally went with a coffee shop theme. So the very first name of Helm was actually Kate's Place. Playing on the pun that K8S sounds like the name Kate, and that Kate's Place sounded like a good coffee shop. And we had all these really cheesy sort of like coffee shop shots and espressos and, that kind of lingo going through there. And so for 2 days, Jack Remus and I spent all this time, hacking away at this cheesy coffee shop theme package manager thing that really was designed to look and feel more like NPM than anything else. And then when the final round of the hackathon competition came down to it, they were like this $75 gift card for Amazon on the line. And, all these teams had built all these interesting demos of, all kinds of various Kubernetes-y things. We were actually up against someone who had taken HashiCorp Vault, which was brand new, and ported that and was running that in Kubernetes. And I was sure he was going to win because that was such a good idea. But we ended up winning a $75 gift card for Kate's Place. I spent my $25 share of that on coffee because it seemed appropriate. And then the day after the offsite, I was back in my office, and the CEO and CTO kind of called me in, and I'm like, uh-oh, the only reason the CEO and CTO ever show up in the same room at the same time is if I'm getting fired. So I came into it like expecting that. And they're like, so, that Kate's Place thing you demoed, that was a really good idea. We think that actually that might be a good kind of thing for us to build. And I said, really? And they're like, yeah, just one thing. We really hate the coffee shop theme. So Jack and I, who had built this first prototype of it, we sat down with a nautical dictionary and we're just reading different words back and forth to each other, trying to find something that felt like it meshed with the Kubernetes, pilot kind of theme and the boat theme. In my telling, Jack said Helm, and I went, yes. In his telling, we both simultaneously said Helm. So if they ever make a movie version of this, that's probably the version they'll make the cut. World's most boring movie, the Helm origin story. We've landed on Helm, and once we came up with Helm, then the rest of the sort of vocabulary sort of just flew out of it, like charts and all these sort of early registries. I think the first version of registries was called a chart box or something like that. But we kind of came up with the whole thing right there. And ironically, not ironically, I guess in some part, Helm played a role in Microsoft's acquisition of Deis, in that, once we had started building a package management system and we started working very much in the open with Google and others, Microsoft went, oh, these people kind of are seeing the future of Kubernetes. And so when Brendan Burns left Google and went to Microsoft, and Brendan Burns was the one who kind of originally started the Kubernetes project. When he moved to Microsoft, he sort of orchestrated the acquisition of Deis into Microsoft, in part based on that fact that we were sort of one of the first companies to A, do the whole PASI thing, and B, really come up with some novel additional add-ons to the Kubernetes ecosystem that weren't just adding another thing into the system, but doing something that was useful and practical and oriented toward bringing Kubernetes into production.
So the fascinating thing about your work there is you created like a brand new registry, like a whole new abstraction concept out of a hackathon for $75. And I love that, the name changed because in software, man, everybody's got their favorite pet name for whatever it is that they're doing. And ultimately it just comes down to like something that you never even thought of, and it catches on, and you really had no say in it. However, tell me what it was like early on building such a huge open source sort of effort, technology platform framework. I mean, it's so influential. How did you and your team sort of manage that initial growth and like allowed it to not fall under itself? You know what I mean?
Yeah. And we went through really three distinct phases. The first phase being sort of like you just got to bootstrap something. The second phase being sort of that big development moment. And then the third phase being sort of the long-term stability one. So in the short term, we got started literally the day after that hackathon ended. Jack and I came up with the name, and then, a couple hours later we had the commit number 1 in what is now the Helm Classic repository, because we retired the entire Git repo later. And we went, okay, so, we just have to kind of think through carefully what's going to be necessary in this first phase of package management. We need to go out and convince some people. So, part of this became sort of like the heads down software development work. And the other part really became going out to the early other teams working on Kubernetes. So it's like Red Hat, Samsung, of course, Google, and, some independent developers here and there. Joe Beta was an independent developer at that point. And we just set up one-on-one calls with them and essentially pitched, package manager for Kubernetes, good idea, bad idea. And, we got that's a horrible idea. I mean, so there were some people who are like highly opposed to it, and others who were going, yeah, actually that's a pretty good idea. So we came out of that going, all right, well, enough people have said good idea that we're going to keep going. We're going to introduce it at the first KubeCon, which was a few months after that. And I mean, this was the KubeCon where everybody fit in one small room, where I think it was like a conference. It was probably like a ballroom at a hotel in San Francisco. And at the time, it felt like such a huge audience, right? You're like, here's my little project. I think it might be good for Kubernetes. And my kids dug up the video the other day, like a couple of months ago, and I'm like, oh my gosh, this is just painful to watch, But it was like, here's my little idea. I think we could use this in Kubernetes, and the feedback we got out of that first KubeCon validated that people wanted something like that. And so we spent the remainder of that year just heads down building what was Helm version 1. In January, after a couple of weeks off, I came back and had some email from some people at Google and some people at a few other places who said, hey, we're all in on this idea. We've been working on our own kind of package managery solution. Let's see if there's an option to merge these things together. So flew out to Google and spent a couple of days working with them. And that became sort of the second phase of Helm's life, where we went from just trying to build something that showed off some value to building what itself gathered a lot of momentum. And so originally Helm was under the Kubernetes project. We had a number of developers kind of come in alongside us. My time was full-time on Helm at that point, and the rest of the day as platform, we handed off to somebody else. And I think, okay, my background's philosophy, right? So in ancient philosophy, there's this sort of duality that causes a lot of strain. On one side, you got Plato, and on the other side, you got Aristotle. And Plato's going, the forms are immutable. Everything that's ideal is immutable, and everything we do as humans is trying to build something that perfectly matches the ideal object. Right. So in Plato's world, he would have said, there's an ideal Helm out there, and you just need to write code until you fit this ideal Helm. And then on Aristotle's side, Aristotle's going, no, everything is always in flux and things are always changing. So the big challenge of philosophy is describing how things change and how they get better or worse over time. And so, ironically, I mean, this is thousands of years ago, right? But ironically, a lot of software, the core tension in software is between these two things, right? On one hand, we've got this sort of insatiable desire in the Aristotelian fashion to build new stuff that does cool things. And on the other side, we got this Plato in us that's like, no, we just need to find the right thing and we need to stick with it. And so Helm kind of went into this Aristotle phase, right? And starting with the interest of Google, where we were just building and adding feature after feature after feature. And at some point, I remember we're like standing around in this physical conference room for the first time ever, sort of all gathered here. And Michelle Donani, who was Michelle Nerali at the time, she was like questioning why we were adding things to Helm. And I was getting really frustrated. And she's like, wait. Let's just write this on a whiteboard. What is Helm? And we're like, Helm is the package manager for Kubernetes. Okay, does Helm need to do any orchestration to be a package manager? Well, no, probably not. That's what Kubernetes is for. Does Helm need to be able to do that? And we kind of walked through what the features of a package manager were. And that kind of helped us focus on saying, okay, this is the thing we're going to build. And that was really the first time that we really buckled down and said, Helm is the package manager for Kubernetes. That's what it is. It's like Debian's package system apt, or npm, back to our roots in the npm ecosystem for JavaScript, and that really helped us sort of refine this is how we're going to manage changes. So we spent a couple of years doing that. We built and released Helm 2, and then the scary part happened, and that was that everybody started using Helm. And suddenly the Aristotelian way of doing things, where we're constantly changing and constantly trying to started to drive people a little bit mad. They were kind of like, but we don't want a new feature every week. We want the same packages to work week after week. And so, this is maybe a year and a half, 2 years into Helm's life cycle when we started to say, okay, we got to switch over and get really clear on stability. That ultimately led us to build Helm 3. So very conveniently, the sort of three phases of Helm lined up with the three major versions of Helm. There's 1.0, which was short-lived, but very highly like throwing spaghetti at the wall kind of thing. Then this phase where we really grew it into a solid package manager. And then in Helm 3, we went, okay, we need to make this stable. We need to do our very best to listen to what people are trying to do and how they operate their Kubernetes cluster and do a package manager system that works that way. And, Helm 4 is just now starting to be a thing that we're talking about, right? But Helm 4 is very much following that Helm 3 guideline of saying, what's important now is that as the package manager for Kubernetes, we are reliable, we are stable, users know what to expect. It solves some problems, but it's not going to end up being the Swiss Army knife that solves all of the problems for everything you want to install into Kubernetes. So, it was definitely a learning curve, and that transition from the Aristotelian, let's keep changing stuff until we love it, to the Platonic, let's just settle in on something that people can rely on was a tough one.
That is the, maturity path for technology in general, right? Like you have something, you keep working on it until enough people are like, we can't deal with breaking changes daily. And then you have to start scaling back. But that's where, once people are complaining that it's changing too much, it means that they're actually invested. Like they don't want it to change because it is working.
Yeah. Yeah. Actually, that's such a good perspective on that. Yeah. Yeah. When people fall in love with what you've built and use what you've built, then you know that you have probably hit the right point.
When it can stick around through a couple of cycles, you've really captured something. I guess, once you were doing it and it was going well, have you handed that over to a foundation, or like how
Mhm.
did you kind of manage the transition, away from, daily coding on Helm
Yeah. Yeah.
and how it's running now?
And kind of a key character in this story is Brian Grant, who at the time was essentially running the Kubernetes project. He just like a couple of weeks ago announced his retirement from Google. He was the right person to drive Kubernetes in the beginning. And Helm was part of Kubernetes at that point. We sort of, there was no foundation. If it was interesting in Kubernetes, it was under the Kubernetes repo inside of, or organization inside of GitHub. And we were starting to kind of gain our own momentum, and consequently we were on our own release cadence, different from Kubernetes. Our stability guidelines were different from Kubernetes, and we were at the first ever Helm Summit, which is a one-day event in which we were talking about Helm. And Brian Grant and I went out for coffee, and Brian, looked at me and said, this isn't working optimally, is it? And I went, you mean like the whole like Kubernetes Helm subproject thing? He's like, yeah, yeah. He says it's we really don't want to have a bunch of exceptions for one project. And I said, yeah, I know, and we really can't kind of conform to how Kubernetes wants to operate the release cycle. So we kind of went, what is the right solution? And he says, well, with Kubernetes going into the CNCF, a brand new foundation under Linux Foundation, one of the things we've always wanted to do was have other projects in there too. Just like Linux Foundation is not just the Linux kernel and nothing else. CNCF needs to go kind of that way too. Would you be open to breaking Helm out of Kubernetes and putting it in CNCF as a separate project? And I went, well, yeah. I think I think that actually would be a really good idea. And so we were one of the first projects after Kubernetes to kind of break out and become a separate CNCF project. And that was a phenomenal experience because, again, scratching sort of my philosopher itch that comes to the surface every once in a while, trying to figure out how to organize chaos, and open source is chaos, right? Trying to figure out how to organize it and put guidelines in place and build repeatable patterns was a lot of fun. And I consider it just like one of the most energizing periods of my career was being there as CNCF got formed, trying to guide Helm as we kind of fit under there. And it took us a long time to get Helm from that early phase of, I guess it would be sandbox project now, but at that point, everything was an incubator, and get that all the way through the full graduation process of CNCF because we really kind of went through growing pains with the foundation. But it was just a fantastic experience. And these days, like, I'm far less involved in the day to day with Helm, far less involved with the day to day of CNCF. But now having a little more of a third party view of things, I just think CNCF has done a phenomenal job of creating an ecosystem that has matured over time, right? I think the problem with some of the foundations we've seen fail is that they get sort of locked in Plato style into saying, this is what we do and this is all we ever do. And, CNCF has been a little more Aristotelian on this front and said, we need to change strategically over time as Kubernetes changes, as cloud native changes, as the, technologies putting pressure on the ecosystem change. And I think CNCF has just done a fantastic job of that in everything from the way they run individual projects to sort of like the way they do KubeCon and the big style governance and the TOC and the tags. So it has been just it's been a phenomenal thing to observe over time, and I consider myself very lucky. My career has basically been made by luck. I just happened to do the right thing at the right time in a couple of ways that have gotten me into really exciting areas of technology, and that was definitely one of them.
That's an amazing story. I do think we could make a movie on it. I think we could get Oliver Stone in it. It could get really dramatic. The moment where you chose Helm. But
yeah.
it's really a cool kind of stepping stone now that you had such an impact. You created this thing, you worked with a bunch of people, handed over to a foundation, and instead of just stopping at that, you went on to build this thing called Fermyon with all the folks that are listening right now are probably wondering, why have we been talking about Kubernetes nonstop on the Talking Serverless podcast? So I have a segue now. We can get to Fermyon. What's the story behind how you started that? And like, what is it? Go ahead and tell us a bit about that.
And this is where serverless goes from a background player right into the foreground. So we were at Microsoft at this point, and my team, the team that I had at Microsoft we had the best job internally at Microsoft. We had two mandates, right? Number one, be good open source people. Microsoft was at this time very much trying to repair their open source reputation. They might have said some kind of negative things at one point about Linux, about open source. And, under Satya's like, nah, this is a great movement. We gotta, figure out how to not just be good participants, but repair the relationship. And so part of my team's job was to do some of that in the CNCF world. And the other part was really to listen to what people were saying about what was holding them up or preventing them from shifting to the cloud or shifting to containers or Kubernetes or any of these technologies that Azure was interested in, right? And so my team really, we pushed, I think in the end, something like 9 projects into CNCF or Linux Foundation. We worked with various Microsoft customers from tiny ones to gigantic ones. We went to pretty much all the KubeCons. We were completely sort of steeped in the emerging culture around cloud native. And, part of my job and part of the cool part about my job was I would go and talk to different service teams at Microsoft and really try and understand what their big problems were, right? What were the things that were keeping up keeping the architect awake at night? And I had this really transformative conversation with a guy in the core Azure compute team. I think the way this happened was we both got to a meeting a little bit early and we were just sort of like, shooting the breeze before the meeting got going. And I said, what would you say is the biggest hardship for Azure core compute? I mean, Azure core compute, people don't realize how absolutely gigantic, how many actual physical servers it takes to run all of Xbox, all of Office, all of Azure, all of that. And so I wanted to hear from this guy. What's the big deal? Now, incidentally, I had asked the same question to a senior architect at Google one time. And his answer was, well, power management is very difficult. It's a very difficult problem to solve, and went into describing how they handle power management. So I expected that caliber of answer from this guy, something that's going to be, I didn't understand anything the Google guy was saying. So I expected not to understand anything this guy said, 5 years later when I asked this question. But his answer blew me away. He said, the problem is, we rack servers literally as fast as we can, and they are claimed for usage literally as fast as we put them in there. But did you know that most of the systems inside of Azure are actually sitting 80% idle? And I went, sorry, what? 80% idle? And he said, yeah, because they get claimed and they're in a Kubernetes cluster and they're running, workloads that are designed for being run at peak, or they're hot swap standbys waiting to be, or they're a frontline web service that gets peak traffic for 20 minutes a day. And most of the times it's, relatively low traffic, but because it has to handle peak traffic, it's over provisioned. And then he said, in Azure Functions, which is Azure's, answer to Lambda, he said we actually keep a giant queue of VM instances, and they just sit there waiting for a function. And when a request for a function comes in, the workload gets dropped onto that VM. It goes and handles that one request, sends a response, and then that VM is destroyed, and a new one is popped on the end of the queue. And he said, so we got this big queue of servers just kind of sitting there doing nothing. I actually went and looked up after this. Well, how does Amazon Lambda work? Why aren't we doing it that way? And discovered that Lambda works the same way. And I'm like, serverless is supposed to be so efficient, right? The idea of serverless was so profoundly efficiency oriented, right? We handle it, a request comes in, we start something up, we handle the request, we return a response, and we shut it down. And magically, we're highly efficient. But the infrastructure sitting behind it was actually turning more and more inefficient as demand for serverless grew. And so I came out of that talk and I'm like, there's got to be a better way. Right. So I went back to the team and went, I think we need to solve this problem. Right. I think there's this big efficiency thing. We could really have a profoundly good impact on Microsoft if we could solve this problem. And so we started trying things out with containers, with virtual machines, with unit kernels, a variety of projects that were designed to kind of figure out a way to nearly instantly start up a serverless function, execute it and shut it down, and not have to have a ton of infrastructure sitting around and not have to have big queues of VMs just waiting. And we tried a bunch of things, failed a bunch of very interesting ways, and learned a whole bunch of things along the journey. But at one point, we started going, well, maybe our core assumption that we have to make this work with containers or virtual machines is where we're making our error, right? Is there some third class of cloud computing that would have the same security properties, but better performance properties and a really good sandboxy model that we could use instead to build a foundation for, a next generation of serverless functions? And that was how we ended up, evaluating some technologies that led us to WebAssembly. And it was a hard one to swallow because WebAssembly was not designed for the cloud. In fact, it was designed to run in a web browser. And the kind of core value prop of WebAssembly was, hey, you can take your old crufty C code, compile it to WebAssembly, and then in the browser, you can use JavaScript to call into these old C libraries. And that was a very specific use case and actually kind of useful one. Figma went the opposite direction, went, well, old crufty, we're going to build brand new shiny C++ vector code and build Figma on that. And they've made tremendous use of WebAssembly, as have a number of other companies who figured out how to work around the weaknesses of JavaScript by building something in another language, one that has different memory management or better, floating point or whatever. And that's where we were seeing success there. But when we looked at WebAssembly's design, we went, this is actually the core attributes you want for a serverless engine. We all know as web browser users that we don't trust every website that our search engine directs us to, right? And we don't want to run arbitrary old crufty C code and give it access to our system. So the WebAssembly sandbox had to be really, really good. In fact, the WebAssembly sandbox is actually stronger than the JavaScript sandbox because you even have to protect the JavaScript engine from being attacked by WebAssembly. And so the security model was brilliant. And that's number one requirement for a cloud platform, is you need a really good, strong security environment. And then the number two was, WebAssembly had to perform really well because, as every browser front-end developer in the world will tell you, users are impatient. They want their site loaded and running right away. And in fact, you start getting dinged if your time to first byte from a request is more than 100 milliseconds. And so they knew they had to have really, really, now compare that with average startup time of a container, which is dozens of seconds, and the average startup time of a virtual machine, which is minutes. When you're talking around under a sub 100 milliseconds, which was the original goal, you're talking about a cut of an order of magnitude. So we looked at that, and we looked at WebAssembly's cross-platform, cross-architecture support, which was fantastic if you're ever frustrated building a container and going, well, the ops team just said we switched from Intel to ARM, so now I have to rebuild every single container that we have. This is a big thing. Even with Amazon Lambda, and this is where we started looking at existing serverless and going, can we even do better than current serverless? Amazon Lambda takes about 200 to 500 milliseconds to cold start, and you have to select when you start what your target operating system and target architecture are, because really everything's just getting piped down to virtual machines. And so really you're supplying information there. And we were going, can we do better, right? Can we move the ball forward just that much more? And so WebAssembly really kind of made a good option.
Did you take a look at sort of the foundations of the Firecracker VM and evaluate that from AWS at all?
Yeah. And so at that time, when we first started this in 2018, we didn't know much about Firecracker at all. I think Firecracker was still probably fairly new, and we started looking more and more at it. And these days, I mean, we also play around with Firecracker even at Fermyon with this other environment because it's cool. Firecracker is cool.
Yeah.
And if it had existed then, we probably would have, if it had existed in its current form then, we would have probably started there and worked from there to see what we could do then. So in a way, it was sort of fortuitous that it wasn't there, because it allowed us to start pushing some boundaries that otherwise we wouldn't have pushed. But it is a remarkable technology. And clearly Amazon developed it because they knew that they had the same set of problems. They just took a different design approach in solving the problems. So that got us kind of going with WebAssembly.
So Fermyon, the company, offers a cloud runtime built with Wasm as a target, right? Is that fair to say, right?
Yep.
For that, you created Spin, which is like a framework in order to build these WebAssembly WebAssembly modules, I guess they're technically called modules, right? That get delivered. Can you tell me about Spin and kind of like how a developer would use it? Because it's a pretty brand new kind of way to think about cloud programming.
Yeah, and we were kind of looking for the right nexus between sort of like the PASI sort of experience, where all your development tool chain guides you right into deployment, right? And the serverless tool chain, which is very much, well, more a design pattern, right? How do you build applications? Well, you think about event handling, and you think about, when this particular thing triggers, I want to do this particular thing to respond to it, right? And so we were really looking at trying to blend those two and build an amazing developer experience, right? Because we know developers are impatient, impatient is a universal trait of humanity, right? But they want to learn something, and then they want to be able to apply it right away. So we knew if we wanted to win them over, we had to do it very quickly. We wanted to bring together the kind of ease of development environment that we were used to from our PASI systems, and also that serverless pattern into one open source package. And so we built Spin, which is an open source developer tool for building serverless applications that compile to WebAssembly. And our first big user story for this. So it took us about a year to build Spin, the first major release of Spin. And we said, okay, our first major user story, under which all other user stories are going to fall, has to be, as a developer, I can go from a blinking cursor to a deployed application in 2 minutes or less. It's got to be that easy. That's the only way we're going to win people over. And so, we started out with a handful of programming languages, Rust, easy one, Go, because Rust has a fantastic WebAssembly toolchain, Go, JavaScript, then Python, and then we're still adding them as we go. And really started to build a toolchain designed to make it really easy to start with your request handler and write just your business logic, right? And then the build tool chain compiles it to WebAssembly, which means it'll run just about anywhere from, sub Raspberry Pi class devices to, 256 core mega boards that you'd see in the data center, and just about everything in between. And we spent that first year just relentlessly pursuing that 2 minutes or less story. Radu, who's the CTO of Fermyon, is proudly proclaimed at the end, we got it to 66 seconds, right? You could do a hello world in 66 seconds. And that included the build time and all of that. From there, we wanted to do a couple of things, right? We wanted to make sure there was an easy place for people to get started and play around with Fermyon, with Spin. And we wanted to make sure that we were able to run a serverless environment where people cared about having a serverless environment. So the first part of that was fairly straightforward. We built Fermyon Cloud, which was our own kind of hosted version of it. It was intended to be for developers to very quickly deploy their weekend projects, right? We know that developers want to get comfortable with the technology, and that the last thing they want to do is spend their weekend trying to figure out an ops problem. And so we made a really easy to use Fermyon Cloud platform where they could just do a spin, essentially they could do spin new to create a project, spin build to compile it, and spin deploy to push it out to Fermyon Cloud and be done in that 66-second window, and then start playing with it from there. But when we got to the second question, that one was hard. Because we went, okay, where do people want to be able to run serverless? And, we've got Lambda, we've got Azure Functions, we've got all of these hosted platforms where there's a strong serverless offering. But we were hearing a lot of people saying, well, what we really want is to run serverless in our Kubernetes cluster. We want to write the same kinds of things that feel Lambda-y, but we want them to be executed in the cluster. And on the ops side, the reasoning was fairly straightforward. They're going, look, company bought into Kubernetes big time. If I have to manage, 80% of our workloads here as microservices running in containers in my Kubernetes cluster, and then 20% of our applications are Lambda functions running over here, I have to have 2 security models, 2 deployment models, 2 very different runbooks. It's a pain. One operator was like, I've got Frankenstein's monster. I've got all this stuff in Kubernetes and then all this other stuff over here. I just want them all to be in the same place. And so we really spent some time saying, okay, we're all Kubernetes people. We grew up in Kubernetes. We should be able to do this. And we started building a Kubernetes runtime. Now, ironically, at this point, we were not the ones who figured out the breakthrough move. It was Microsoft who figured out the breakthrough move. And they released this tool called Wasm that basically piped, redid the plumbing in Kubernetes in a totally Kubernetes compatible way, where if you scheduled a container, it ran in the container runtime. And if you scheduled a WebAssembly module, it could run in a WebAssembly runtime. And literally, you could describe all of your applications the same way, whether they were container-based or whether they were WebAssembly-based. And it just piped everything down into containerd. And so you were writing pods and you were writing deployments and all the usual kinds of Kubernetes YAML-y things, but you could orchestrate either one. Either containers or WebAssembly. And when they released that and open sourced it into the containerd project, we went, there's our answer. So we had tried a couple of other ways. We tried Krustlet, which was sort of like our first attempt. It did not work well. We tried a couple of other things where we were encapsulating WebAssembly runtimes in various, mid-tier layers, running on top of Kubernetes, essentially. But once Wasm came out, we went, okay, now we have a clear path toward running serverless functions side by side with containers inside of a Kubernetes cluster and using all the things, right? Service meshes, volume mounts, all the regular Kubernetes things that everybody is comfortable with, and just attaches them to WebAssembly runtimes and uses them in this kind of serverless capacity. So in March at KubeCon in Paris, we announced with Microsoft and SUSE and Liquid Reply and a few others, that the SpinCube project was an easy way to run a whole toolkit for running Spin applications inside of Kubernetes. And then we announced that we were contributing that into CNCF so that would have the same common governance that everything else did. And that was, it was a cool thing to announce, right? But internally for us at Fermyon, that was a real watershed moment because we were, in a way, sort of returning to the Kubernetes roots that had led us to this problem in the first place, but in a way bringing something that we are really genuinely amped up about in the form of this, lightweight, ultra fast serverless architecture. And at this point, we had gone from cold start times of 100 milliseconds down to cold start times of half a millisecond for these WebAssembly runtimes, which meant we were providing Kubernetes people not just with the ability to run serverless workloads inside of Kubernetes in a very, very simple way, but also to give them a really high performance local alternative that it would allow people to run them on, everything from their Kubernetes account in AKS or EKS or whatever, down to, environments like SCIFs or completely detached environments that didn't necessarily have internet access. And it was just fun, right? It was just one of those moments where we went, we had this vision in our heads for a couple 2.5 years, right? And for the first time, we're watching the vision out there in reality and watch people use this kind of thing and say, yeah, this gets me past the Frankenstein's monster concern. I like the way this works. And that's really where we are kind of today.
Nice. Nice. I mean, it's exciting to bring serverless to a world that immediately was like kind of the opposite of serverless, right? Like when
Mm-hmm.
I'm dealing with if I have
Yeah.
to deal with a Kubernetes cluster, I am way too deep in the stack, right? Like
Yeah. Yeah.
if I have to set up, gateways and network ports and all of these volume mounting, all of that
Yeah.
stuff.
All the things you don't ever want to touch, right?
If I have to actually use a shell command on a machine, I know I've messed up. That's what I tell people. Like,
Yep. Yep.
as you kind of created this serverless solution inside of a hosted Kubernetes environment, like, what can developers expect for things like local testing, like local debugging, or access to things like queues and metrics and logs and something further beyond just the function execution? Because I saw that you do have like a key value store maybe built into the runtime, which is interesting. Yeah, tell me about kind of like the ecosystem that you currently have.
And this is where we get into what makes WebAssembly such a cool technology, right? So you can think of WebAssembly as you've got guest code, the code you write that's running inside of a host, right? Because when you think about the way virtual machines work, right? A virtual machine is an entire operating system packaged up. And then you bootload it, right? And you run it just like an operating system. When you think about a container is basically giving you like a little pie-shaped slice of an operating system. And you're running your core unit of work is a long-running process, right? That's going to access the file system. It's sharing the kernel with other things, but in a secure sort of way. WebAssembly's entry point is in code, right? Like serverless, right? It's an event handler function. But because of the way the WebAssembly environment works, you can expose APIs into the guest and say, hey, the runtime is providing a key value storage system. There's this whole model called the WebAssembly component model that basically says, here's how you can describe to one WebAssembly component, one WebAssembly module, what imports and exports are available to it, right? And it's similar sort of in theory to the way gRPC works or something like that, where you can say, hey, here's some functions, here's some data structures, you can use these as you like, and except it's really at a lower level. So we can say to a spin developer, here's a key value storage API. It's going to, anytime you're running in a spin environment, in a spin compatible environment, you have key value storage. When you're running now, that's really all the developer practically needs to know. Okay, so I can get, I can set, I can delete, I can list, all my regular things that I would use. But then the runtime can determine sort of how that is satisfied. So when I'm running locally, the spin built-in way of doing this is there's a SQLite database and it's got a key value storage table in it, and you're doing everything locally. Inside the guest code, it's identical to if you're running in production. So if I push that out to Fermyon Cloud, instead of using a MySQL database, it's using our in-cloud key value storage system that I think is backed by Postgres in Fermyon Cloud. So again, a relational database is basically acting as a key value system. But if you deploy it into Kubernetes, then you can choose to back it with Redis or with whatever other key value storage system. So what we've done here, and this is, I think, one of the biggest friction points in cloud, what we've been working on doing is separating the responsibilities of the operations team, the platform engineers, from the development team. the development team should be able to work at the programming language level, right? And say, I need a database, I need a relational database, I need a key value storage, I need a secure vault to store my secrets, I need environment variables, right? And those are, and I'm going to access them through the system APIs, right? The platform engineer should be able to say, this is the topology of our cloud, right? And this is how things are laid out in our Kubernetes cluster, and these are the volume amount styles that are available, and these are the databases that are available. And the developer should be as unconcerned about that as possible, right? SQL's a weird one because you do have to know the SQL dialect. Key value storage is almost the opposite, where it's like, if it can take a key and a value, who cares what's sitting behind it, right? And so we constructed the environment to really act that way. And so the Kubernetes operations team can say, hey, when we install SpinCube to run in Kubernetes, this is how we want key value storage to work. This is how we want SQL database to work. This is how we want volume mounts to work, and not have to know anything about the developer's code. Meanwhile, the developers don't have to know which things within reason the operations team suggested. So the local development story is fairly straightforward. You write your code locally, you run spin up, and it starts a local server that's got key value, got SQL, got environment variables and file system access for a virtual file system and stuff like that. You can write your tests and use spin test to run your test locally. And then when you deploy it out, you know that it's going to work, right? Because you know that the contract you've got locally, the description of how it runs locally, that same contract is going to be fulfilled remotely when you do a spin deploy. You might not know what the underlying technology is, but it'll work. So that was the way we kind of built it. And a big part of the reason why goes back to one of the things that frustrated us when we were first getting into serverless. Again, this is like 2017, 18 when we started this whole journey. And it was very frustrating to build Cloudflare workers or to build Lambda functions and not really know until we deployed whether it was going to work, and not really have a good, strong paradigm for how unit testing should work in that environment. And we said, okay, well, we want a better developer experience. We want this part to be easier for users of the whole spin ecosystem. And so that's kind of the approach we took. The big kind of magic piece behind that is the component model. And that's what's exciting to me going forward is component model allows you to the host to say, here's a database, right? But it also allows guest modules to say to each other, hey, I can supply this library. I can supply a YAML parser. I can supply an SSL configuration. And regardless of the language in which a component was written, the WebAssembly developer can use it. And it feels very much like doing your regular imports in a programming language, but I can use, the best Rust implementation of a TLS library from the comfort of JavaScript, which I am much more I don't want to say better because that implies that I write good code, but much more confident in JavaScript than I am in Rust. So you get sort of a polyglot programming effect out of this as well.
I mean, with Spin and the way WebAssembly modules are working for you, it's almost, I can see another dependency manager or like another sort of platform level module system, like NPM again, right? Like if I'm building a Spin app, I can Spin install TLS and it'll give me that module or whatever.
Exactly.
Right?
Yeah. I'm going to do a coffee shop theme. No.
Exactly. It's got to be a espresso spin or something,
But actually, much of that work has sort of been done or is in progress right now by the WebAssembly ecosystem itself. So Bytecode Alliance is the name of the organization that kind of shepherds along standards. The official standards body is W3, the same one that does HTML and CSS and all of those. But Bytecode Alliance really does sort of the reference implementations and writes the specifications, and then they submit them through W3 to be validated. And they've been working for 2.5, 3 years on package management. Unsurprisingly, turns out that the best way to deploy packages these days is through OCI registries, or what we would call, a Docker registry, because you can package a WebAssembly binary in the same way you package a Docker image, and that ecosystem is so well supported at this point that that's really kind of been the main way that it's been.
I mean, when I looked at the Hello World and the Get Started stuff for Spin, the thing that stood out to me the most was like the infrastructure as code piece really isn't on its own, right? Like I think there is a TOML, but there is a TOML manifest, but it's not like this heavily super nested like YAMLs of YAMLs of YAMLs.
Yeah.
for handling all the dependencies as it deploys to the cloud, right? Like, because I'm assuming with Fermyon Cloud, all of those conventions are already packed into the framework, right? So when a developer is writing and deploying these things, they don't need to manage like a huge CI system.
Right, right. And I mean, it integrates well with existing CI systems, but ultimately, your artifact is a WebAssembly binary file, right? And that spin toml is basically just the glue that says, here's the configuration you need to attach to this thing, and really more a developer oriented piece of code, not an infrastructure oriented.
One last thing I wanted to get your thoughts on for WebAssembly is how is it working on the back end? Because, like you mentioned earlier, it was designed to be run in a browser as like a JavaScript call, like an init call. It instantiates this class of thing that the browser can then interpret the binary, right? But on the back end, on the server side, how is WebAssembly being, I guess, orchestrated for like function calls, right? Like, is it like a JavaScript engine that has to take it in, or did you write some special secret sauce or whatever?
Yeah, the problem is exactly as you describe it, right? If I'm running something in the browser, what do I care about? Well, I care about a DOM, and I care about a page load, and I care about, a button click, right? And that's one ecosystem. When I'm writing something for the server on the server side, right? Or when I'm writing a serverless application, what do I care about? Well, I care about an inbound request. I care about a file system. I care about environment variables. I care about database connections, right? And so you know you how do you do that, right? This core specification of WebAssembly is actually just defines the bytecode format in the instructions, and it doesn't define the APIs. And then the browser part of things defines the APIs. So what was necessary was to build a server-side version of this. And again, Bytecode Alliance is where this work is done, because we wanted to do it together in a way that was very standardized. And so there's this thing called WASI, the WebAssembly System Interface. And WASI says this is how a WebAssembly runtime can work at a system level instead of at a browser level. And it says, here's what environment variables would look like. Here's what the component model looks like. Here's what a file system would look like. And so any runtime, any WebAssembly runtime that matches the WebAssembly specification and the WASI specification should be able to run a binary that was compiled for that, right? So a spin application. So that means that you probably don't want to run the full web browsery version of something. So for example, you could try and do this all in V8. Instead, what we do is we use the Bytecode Alliance's WebAssembly runtime, which is called Wasm time. And it is the WebAssembly plus WASI runtime versus V8, which is the WebAssembly plus browser runtime. And that's how we've been able to make that kind of work. Wasm time's written in Rust. It's ultra high performance. And I have tried to read the code on a number of occasions, and I am not smart enough to understand it. So, I mean, it is just brilliant code.
That's wild, because for JavaScript developers, this past year has been all about the different ways to execute and interpret JavaScript, right? Like, we've got Node, getting even bigger. We've got Deno coming out, and then the folks at Deno have their own JSR, which is a new NPM thing. And we've got Bun, and Cloudflare workers are technically a different JavaScript runtime.
Yep.
And like, I'm seeing all of this change because, again, people have decided like JavaScript's pretty good. Like, as much hate as it gets, like, it does a lot, and it does a lot really well, and it's very accessible. And I see this as the market pointing towards, let's go JavaScript, right? And I'm all about that, because I normally just write JavaScript and
I'm a huge JavaScript fan.
oh man. So we've been chatting for about an hour, and I don't want to miss out on the most important questions, the hard hitting ones.
Uh-oh. Where can you buy a shirt like mine? No.
Oh yeah, totally. The deep, aka philosophical questions, because I did a quick Google search, and I saw that you had a fancy dissertation, and I read through it. It was super cool, and I thought, man, now that I have somebody who's both in computer science and in philosophy, the natural bridge are paradoxes. I wanted to get your favorite paradox and to share that with our listeners.
Every philosopher has this love-hate relationship with paradoxes because it's an easy way to churn out a new philosophy paper, but also you're going to have a million people tell you why you're wrong. And we in computer science like to ponder paradoxes, but we just have a hate relationship with them because a paradox means a problem we can't figure out how to solve, and that drives us absolutely up the wall, right? And so there's some good ones, but I think my favorite one is actually one of the lesser known paradoxes. It's called the Sorites paradox. And a Sorites paradox comes from, I think it's from the Greek. My Greek is not good. I think it was like Soros or something, but it means pile or heap, right? The intention of this one is to show us how unclear our reasoning is and how weak some of our what we'd call epistemic judgments, knowledge judgments are. And the paradox goes like this. Imagine you're at the beach, right? And you pour a pile of sand onto a plate, right? What do you have in front of you? Well, I got a pile of sand, right? Okay. Take a grain of sand off of that pile. What do you have? Well, I got a pile of sand. Take another grain of sand off. Well, I still got a pile of sand, right? As you keep going, over and over again, you're plucking grains of sand off of this thing and you're still left with a pile of sand. Then at some point, it's not a pile of sand. But what is that point? How do you get there? So I like this one because in programming language talk, it's like, okay, imagine writing a piece of code that's like, I got a pile of sand. Okay, now my code is going to subtract one from the pile and then do the isPile function on it, right? What does the isPile function look like? How do I know? How is it not just completely arbitrary that at some point I go, I don't know, maybe 15 grains of sand isn't a pile anymore, or maybe 1,000 grains of sand isn't a pile anymore. And the cool thing about this particular paradox and why I think it's so interesting is that it speaks right to the heart of what we're trying to do when we write code. Right? We have this deductive system of reasoning, and we have done mind-blowingly profound things with this system. Right? I walk around with a device in my pocket that can answer questions when I ask it and show me where I am on a map and call my loved ones and all this kinds of stuff. We built amazing things. And yet still our language is so unclear that we're not entirely sure at what point the pile of sand is no longer a pile, right? And it just very much emphasizes this idea that the rigor we need to be able to do when we write code is one that we don't even practice in our day-to-day linguistic. We're not practicing it today as we talk back and forth, right? We're not precise enough. And that jump from how we communicate in this casual kind of way that you and I have been talking to how we have to write code in this very specific way is actually kind of a marvel, right? It's kind of like surprising that we have built this, beautiful edifice on top of highly imprecise language, which really gets us down to what is software? Well, software is our attempt to take our everyday language and the binary deductive language of a processor and find the happy path in between where we can articulate to the machine how it needs to do some things. And then we end up writing unit tests to say, did my isPile function work? So there you go. That's one of my favorite paradoxes.
That's awesome. I didn't know about that one. But it led me to realize, so my background is not in computer science or math. I'm just like a business major. And when I started teaching myself to code, eventually I came upon this word called a heuristic. And then I learned that a heuristic is just a human's guess encoded into the system, right? Like the heuristic is that we tend toward this variable so that at that sand pile breakpoint, we as humans make the arbitrary decision in order to make it a binary outcome. We say, well, this is a heuristic. We're going to tend towards this variable. And then as soon as I got that, I was like, man, I am so mad at all the academics because you led me to believe that this stuff is super complicated when in reality, it's not super complicated. But I do love that paradoxes exist because life is analog and not perfectly functioning, like not a perfect function to describe everything. Well, that's awesome.
Yeah.
So we've had such a great time today talking about Kubernetes on a serverless podcast and then achieving some next level reasoning using, philosophical doctrines and high-end computer sciencey stuff. But thank you so much, Matt, for coming on. Before we get off, is there anything else you want to shout out or tell people to go check out? Where can they go?
We've talked about the complex stuff, but again, Spin is a fun platform that's designed to get you going in like 2 minutes or less. So if you want to try it out, the easiest place to go for that is developer.fermyon.com/spin, or you can go to fermyon.com and follow the conveniently located click trail to get there. But that's, as summer rolls around and your colleagues are gone and you're like, what am I going to do to fill this afternoon? Because everything's stalled out. This is a great time to be able to play with new technologies. And I hope Spin is one of them that you're intrigued enough to try out.
Awesome. Awesome. Well, thank you so much, Matt. And to the rest of the listeners, thanks for checking us out. Be sure to leave a like and a comment, subscribe, do all the interaction things. And with that, I guess we'll sign out and we'll talk to you next time on Talking Serverless. Bye, everybody.